In this video, we'll be combining two Staphylococcus species. These are Staph epidermidis and Staph saprophyticus. We're going to call this scene Beauty and the Plumber. Without further ado, let's get to drawing out the backdrop of the scene. You'll notice we're using a lot of violet color. This is to signify gram-positive, because gram-positive organisms take up a lot of crystal violet stain. Our structure for this segment will be to discuss unique features of epidermidis first, then those of saprophyticus, and finally we'll talk about their shared features at the end. We'll be illustrating all of the unique characteristics of Staph epidermidis around this plumber right here. So first, you should know Staph epidermidis is the enemy of orthopedic surgeons. It often infects artificial joints and other implanted hardware. So we've drawn a bunch of hardware down here that the plumber's working on to remind you of that. Now we'll draw some tubing down here under the sink that look like catheter tubes. This is because indwelling catheters are also important sources of infection of Staph epidermidis. Staph epidermidis is everywhere. It's given the name because it covers all of our skin, so when you penetrate the skin with a line, it makes sense that Staph epidermidis would be the culprit of these infections. Finally, the third major area of infection for epidermidis is really the same as the first. It's an infection of an implant, but it's slightly special. You have to know that it's the most common cause of endocarditis affecting artificially implanted heart valves. So we'll draw some valves over here, and one of them will be shaped like a heart. And this is our symbol for endocarditis of artificial heart valves. One reason epidermidis is so good at infecting prostheses, implanted heart valves, and catheters is because it's found a way to stick to sleek metal and plastic surfaces. It produces copious adherent biofilms, which is a mess of polysaccharides that not only helps it stick to surfaces, but it also acts as this coating that protects it from exposure to antibiotics and immune cells. So to help you remember these biofilms, we'll draw a bunch of gunk under the sink, coating all of the pipes and tubes and valves. I think that's pretty intuitive. Because epidermidis is able to produce these biofilms, it's resistant to many antibiotics. So you have to really bring out the big guns. Current guidelines state that you should treat suspected Staph epidermidis endocarditis with vancomycin. We'll draw the vancomycin van outside of the kitchen window. Remember, we used the caravan in Staph aureus, but that's only because after doing extensive research, we found out that vans didn't exist in Moses' time. So we'll continue to use this van symbol in future drawings. Also, you should know if any implanted joint is infected, it's more than likely that you'll have to replace it. Staph epi is a nasty little bugger. If you were to draw blood cultures on me, there's a really decent chance that Staph epi would grow, even though I'm not really infected with it. Or at least I hope I'm not. But this is because, as I mentioned earlier, it's normal skin flora, so it's everywhere and can easily contaminate cultures when blood is drawn. So to remember this, we're going to put some dirt on our plumber's hands, representing that it's covering the skin and part of his normal flora. And then we'll draw this drip pan over here, which looks a lot like a blood culture petri dish. We're showing dirty liquid dripping into the culture, which altogether is representing contamination of blood cultures. Alright, so we're almost done with Staph epidermidis, but there is another thing that you should be aware of. One of the attributes that distinguishes Staph epi from Staph saprophyticus is that Staph epi is novobiocin sensitive. This can be a tough one for students to remember, or at least it was for me, but I think we've figured out a great way to eliminate any confusion. Novo kind of sounds like navel. Navel as in belly button. So we're going to expose the plumber's navel here to help you remember novobiocin sensitive. Yeah, his stomach's hanging out, but he's a plumber. He could lose a little weight, he knows. He's working on it. He's sensitive. His navel is sensitive. Since that's all for Staph epidermidis, let's move on to cover Staph saprophyticus. She'll be represented by this young lady sitting on the counter. Really quickly, notice that her navel is not exposed. She's novobiocin resistant. Sensitive, resistant. Sensitive, resistant. Never forget it. Truthfully, you probably won't get too many questions on Staph saprophyticus, but there are a few things you should know about it just in case. Staph saprophyticus is a common cause of urinary tract infections, specifically in sexually active females. This is why we made our saprophyticus girl look as sexy as a cartoon can, twirling her hair and all. This should help you remember saprophyticus's association with sexually active females. To help you remember that Staph saprophyticus causes UTIs, we're going to give her our UTI symbol, which is a yellow drink that is shaped like a bladder, and it has these two straws coming out of it that look like ureters. Pretty cool. Again, this is a symbol you'll see in future drawings. Now we're going to illustrate all the attributes these two have in common. First, both of these microbes are catalase positive. To remember this, we'll have our catalase positive cat sitting over here on the counter. And all of the staphylococci are catalase positive, so this is one way you can tell staph from strep. This next fact is kind of random and not really important for these two microbes, but both are actually urease positive. It's more important for Proteus and Klebsiella, which you'll see in future videos, but I'll explain it here. Urease converts urea into ammonia. So our symbol for urease positive is this ammonia spray bottle, a household cleaner. You'll see it every time we're dealing with a urease positive organism. Last and most important of the shared characteristics is that you should know that both of these microbes are coagulase negative. This is in contrast to Staph aureus, which is coagulase positive. In fact, you'll often just hear Staph epidermidis referred to as a coag negative staph, and they won't even mention the name. So to remember this, we'll have a bowl of Jell-O here on the counter. The Jell-O is untouched with a nice smooth and liquidy surface. It doesn't look coagulated at all. Remember how in Staph aureus the Red Sea was coagulated? To make sure you get the comparison between the coag negative here and coag positive Staph aureus, we've added this little subtlety. Notice the Jell-O brand is Moses' Jell-O. This will help you make the connection that coag negative separates it from Staph aureus. We also made the hyphen red, so it looks like a negative symbol. And that's it. We knocked out 2 microbes in one cohesive sketch. I hope you enjoyed it.